So one thing we have left to talk about, for those of you who have tried to do the 1-3 homework, there's a reason that part of it didn't make sense because we didn't talk about it yet. So, yeah, we definitely didn't finish up chapter 1. So, am I focused over there? That's kind of far away. I'm going to figure this room out eventually. There we go. Okay. Alright, so, spirit of fake news, let's make up some data. So I do have, like I said, group work handout that's got actual data. It's from last semester, since not enough of you have filled out the survey yet, so I have data from them. But right now we're just going to make up some stuff. Well, let's see now. Actually, I want to be a little more... Yeah. Oh, yeah, that's right. They just give it to you. All right. I'm going to give this to us in order, which is nice of me. You can almost read some of this. All right, that's plenty. Okay. So let's say these are ages of people waiting at a bus stop. Just to say it's something. And what I want to do, let me give this to you. What we're going to do is we're going to collect these together and create what's called a frequency distribution. So what we're going to do is, I'm going to give you some classes to work with. So what does that mean? Let me figure it out real quick. We're going to go over the math that I'm doing in my head in a minute. So let's say 11 to 18, 19 to 26, 27 to, you can do it, Jeff, 34, 35 to 42, 43 to 50. Yeah, that catches everybody. All right. Again? Because there were two. Why are there two whats?
Because there were two people that were standing at the bus stop that both were 24.
Yeah, they were both 24 years old. That would be horrible if you came to a bus stop and I'm 44. There's already somebody who's 44 there and I just disappeared. Shit. Anybody 44? No. Okay. No. So that's, I mean, yeah. So repeats in data, you never neglect them. People always ask me, some of the stuff we're going to do today, you're going to be like, do I write the repeats? Of course you do. Because otherwise you're misrepresenting the data. So if I had 28, 24-year-olds, and then a few other people, and I put 124 down, I'm misrepresenting the data. So these, does everybody kind of, you don't see where this came from, but these are what we call classes. And now I want to say, well, how many people were between 11 and 18 years old in my sample? Two. There are two people. So this is what's called the frequency. So if you tried some of this homework out, this should sound vaguely familiar. Yes, ma'am?
Possibly for 7.
Well, here now, this is interesting. The class width here. So when we get into the full-blown creation of a histogram, I'll tell you how to calculate the class width. So if this class starts at 11, and this class starts at 19, what's the width? 8. Okay, I like it. And then 8, 8, 8. Cool, I like it. So the class width here is 8. I like it. Maybe it's...
So when you're creating your class width, is there a certain number you have to go with based on how many classes you or how many members you have, how much data you have?
All right, so I love it. All right, let's just go ahead and talk about it. I love how 1.3 in this book sort of blends into section 2.2, because 2.2 uses what we're doing right now. I might as well just give you the whole picture. How the hell did I calculate the class width of 8? Okay, so how many classes do I have?
5.
I chose that first. We always use between 5 and 10 classes. For this class, we're going to use between 5 and 10. All right, so don't use 4 classes, not enough. Don't use 11, that's way too many. In fact, for the size of the data I'm going to give you, you should really only use like 5, 6, or 7 classes. Maybe. So if I gave you like 10 data points and you use 10 classes, that's kind of silly. Because maybe each of them get 1, or one of them gets none of them, and one gets 2. It's too spread out. Okay. So tell me this. What is it about my classes that made me feel good about, I don't know if you guys heard what I said when I got here. It's like, oh good. Why was I happy here?
Because it evens out.
Because every data point has a place to go, thank God. Right? Yes, ma'am.
You end on the largest statistic or
Data point?
yeah.
Not necessarily. This didn't have to be 50. It just needed to, the highest data point had to have a place to go.
Yeah, so I'm asking if you end on the high.
Not necessarily. As long as it ended at 50, 51, 52,
Okay.
I'm happy. Like it. Maybe. Yes, ma'am.
You always start to your lowest data point?
Normally you start with the lowest data point, but you actually don't have to. Right? If my class width was 10, I might want to start at 10, even if my lowest data point is 11. You see what I'm saying? Make it 10, 20, 30, 40, 50, 60. That sounds nice. So that's humans. But normally you do start at the lowest data point. How are we doing? Yes?
So let's say you didn't end at 50, would you have to do another count? So that all of them.
Yeah, actually I wouldn't have had that problem. If that was bigger, I wouldn't have used a class width of 8. My class width would have grown so that it would capture that last one. And let's figure out how I figured that out. Because I did some math in my head to figure this number out. What the hell math did you do in your head, Jeff? Because you're going to have to do it yourselves. We'll do it in a second.
Isn't it something like you use the lowest number and the biggest number and then divide by the classes?
Something like that. Actually, it's exactly that.
So each class has to have, or each section of the class, whatever, has to have the same amount of numbers?
No, definitely not. In fact, very quickly, before I talk to you about how I created this, once you have them created, let this be easy. You don't put 777 because 11 through 18 is 7 or something. How many people were 11 through 18 years old? 2. How many people were 19 to 26?
6.
3, 4, 4, right? 1, 2, 3, 4. Cool. Is that cool? And then 27 to 34?
3.
1 to 3. 35 to 42? 1. 43 to 50? 3. Yes, ma'am.
Can you use tally marks instead of numbers?
Yes. But then at the end of your tally mark, actually put the number. You know, so you can work with it. But the tally mark you can do if you got a huge set of data, tally mark, telling me bananas right end. But definitely put the number at the end. I like it. Okay, does that make sense? These are not all going to be the same, because that's the purpose of this, is to see where do the data seem to fall the most. Right? So some of you guys, just to talk about something, we're going to talk about all these different distributions of data. And how are grades normally considered to be distributed? Does anybody know? Yeah.
Normal curve.
A normal curve. Or a bell curve. You guys heard of the bell curve?
Yeah.
Yeah. Or when somebody curves their grades, they could pick that bell up and move it. Let's see, the highest grade was a 40. Oh shit. Let me pick that up and make that a 90. You know, so, you see what I'm saying? Okay, maybe. So that would mean that it has low amounts here, it goes up, and then goes down. So it has this bell shape to it. Right? Do grades have to follow that? Of course not. I like it. But like IQ scores definitely do. They're kind of created to do that, to be honest. All right, how are we doing with everything that's happened so far? So let's take a step back. Yes, ma'am.
So why is the class 8?
Oh, beautiful. Here we go. I'm going to show you. You ready? So in section 1.3, they're just going to tell you what classes to use. In section 2.2, you're going to be doing this entirely on your own. You've got to create your own classes. So I'm going to show you right now how I got this class width of 8. Okay. So, how far do I need to be able to go completely for my classes. I have to be able to go from 11 to 15. So what's the range there of the data? How far does the data range?
39.
Yeah, so I have to do 50 minus 11. I have to do high minus low. That's what's known as the range. Let that just make sense. That's how much the data ranges over. I like it. And then I want to know, this is why I got to pick the number of classes I want to use. If I pick more and more classes, what's going to happen to my width? If I used one class, it's going to have to be 39 wide, right? If I use two classes, they are now going to be smaller by how much? Half as much. If I use three classes, I'm going to cut it in thirds. Oh shit, so how many classes did I use? 5. Divided by 5. So divided by the number of classes. This will tell you how much of this goes in each class. Right? When I divide that, I'm going to end up with per 1. So it's going to tell me how much per 1 class. So that'll be the class width. Dear God, always round it up if it's a decimal answer here. Do not just use the decimal. Don't. Why do that to yourself? Yes? So for the smaller the sample size, you would use 5. Yeah. 5 or 6 is a good, for this, for the ones I'm going to give you, 5 or 6 is a good number to use. But the larger the sample gets, the better resolution you want to get. So then you can use 7, 8, 9, 10. There's actually a formula for it using logarithms. Does everybody know what a logarithm is? So do you want to use that? No, okay, good. So the rough idea is the smaller the sample, the closer to 5 classes you use. The larger the sample, and I'm talking about hundreds, you start to go up towards 7, 8, 9, 10. Does that semi make sense? So if I give you like a sample of 30 and you use a class number 9 classes, I'm going to say something. That's crazy. You don't have to use 9 classes for just 30 numbers. All right, maybe.
But you want a minimum of 5, right?
Exactly. Don't go below 5. I like it. Yes.
So calculating the range tells me how many, how the width of each class.
If I take the range divided by how many classes, I'm going to figure out how much each class has to cover. So that together, all of them cover the whole range. Does that make sense? I mean, let that make physical sense. Normally what I do is I say, let's say I'm insane and I want to put wood paneling along this orange wall here. Right? You're like, well, I don't know what's worse, orange wall or wood paneling, but so let's say this wall is about 30 feet, right? And I want to use 6 panels. Well, how wide would each panel have to be?
5.
Yeah, 30. How far it's got to go. Divided by the number of rectangles, the number of, in this case, wood panels that I want to use. So that makes physical sense. It's exactly the same damn thing I'm doing up here, right? I like it. Maybe. Because what I'm going to, my goal, by the way, this is going to be, what's 50 minus 11? Divided by 5?
7 point something.
Yeah, so it rounds up to 8. So 7.8, so it rounds up to 8. Yes?
It was 7.2.
Oh, good. Now think about it. If it was 7.2 and you rounded down, physically, what's wrong with that?
Not everyone will fit.
Yeah, I'm going to lose a few data points. I'm going to have a little orange showing at the end, right? So I want to overcover, which is really going back. If this was 52, you didn't do anything wrong. It's just making sure that everybody's got a place to go. I can overcover it for sure. All right, how are we doing so far? No? So it doesn't have to exactly fit the data. That would be a little much to ask for this poor little thing. It just has to make sure that all the data fits. So that's why if I use 7.8, the data will perfectly fit. But I'm going to have these disgusting numbers to work with. So then I'm not going to do that to myself. I'm going to use 8. Yes?
So, you're doing 7.2 use 8.
Yes. beautiful. Always round up so you over cover. You want to make sure that what you use includes the whole range. It fits in. Okay, let me stop there for a second. How you guys doing? The group work involves 2 problems dealing with this. So it's not like you're going to suddenly, I'm going to lecture and then say, that's the last I'm talking about that shit. Right? So don't freak out if you haven't fully got it yet. Okay, maybe. Okay. So real quick, the goal is to make something that you should be familiar with. Is to make a shape like that. Who knows? Something like blah, 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 blah. Right? You guys with me? That's our goal, is to end up with this. And that's why I was saying rectangles make sense, because it's exactly, here's my wood paneling. Right? Maybe. I love it. Such a wide range of reactions on faces. Okay. How many data points do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And what happens when I add these up?
13.
Thank God. Oh, it so desperately sucks when you have 80 data points and this comes out to be 79.
Oh yeah.
Yeah, I missed one. Why? Where did I miss? Oh, so be very careful about that. If that happens and you don't have time to figure out what went wrong, write down here, I know this should be 80 or whatever. Because if you don't say anything, I'm like, do they even realize that they missed something? You're going to lose more points if I have to guess that you don't have a clue what this is supposed to be, right? Is everybody with me?
Yes.
So that happens if you get a probability that's bigger than 1, for example. Do you guys understand that's not possible? I'm sure your coach might say you can give it 110%. That's mental bullshit, right? Which is fine. That's great. I love it. Give more than you thought you could. But if you say there's a 110% chance of rain tomorrow, does that mean that the raindrops are going to be bigger than normal? What the hell does that mean? It's going to rain so much. I don't know. You guys, so the largest probably can be 100%. So if you're doing a problem and you get 120% and you can't figure out what you did wrong, say, I know this shouldn't be 100. I know it should be less than 100%. So, dear God, say that. Or else I'm going to go, shit. They think that's okay. All right. So in general, you can do that. Please do that. If you don't have time to figure out what you did wrong. Okay. Something that's slightly better than just these pure numbers is percentages. Humans, we created percentages so that we can feel feelings out better. So how do I calculate the percentage that's in each of these classes? And we call this relative frequency.
The frequency of each class and divided by the total number of data.
I love it. So how many data points are in this first class? 2. Out of how many total data points? 13. So what is 2 divided by 13? Give me 3 decimal places. Who's got calculators happy?
4.154.
154?
Yeah.
So it's 153. Okay. So is that cool? I'm just going to make it 15.4%. Is that cool? I'm going to assume we all know how to make a decimal into a percent. Hopefully it's not too big of an assumption. If you have any trouble with that, I don't know if you've ever seen decimal percent, write it in alphabetical order. And if you want to go from decimal to percent, you go that way. If you want to go from percent to decimal, you go that way. Bam. Problem solved. Because of course, what does the percent symbol mean? Divided by 100, right? Out of 100. So when I divide this by 100, it's going to become smaller. That's why if I want to make it a decimal, I got to move the decimal place back. Cool. I like it. Just in case anybody has trouble with that. If you have trouble with that, oh shit, you're going to have trouble with a lot of stuff in this class. Here, 4 divided by 13.
3.7.
30.8%.
3.0.
Yeah, 30.8%. This is twice this, of course, you guys see that?
Yeah.
2 out of 13, so 4 out of 13 is twice. 3 out of 13. 20.1. Okay. And then 1 out of 13. 7.7. And then 3 out of 13 we did already. Yay, chef. Get out of there. Okay. The math here is not intense. It's just understanding how to do, why does the class width make sense, how to get it. You can memorize the formula, sure, but why does it just make sense? And then it's not a memorization, it's just you do it because it makes sense.
Sorry, that's class.
So these are the classes. I like it. Maybe? Yes?
So this will be for a question asking about relative frequency.
Yeah, so this would be for a relative frequency distribution. That's what we have so far. This is the frequency distribution. Here's a relative frequency distribution. And you see why we call it that? It tells me how the data is distributed amongst all the classes. That's why we call it frequency distribution. Okay, maybe. So one last thing that section 1.3 does to us that I'm not overly concerned about, to be honest, but I'm going to put it up here. It's just cumulative frequency. You just add these things up as you go. Cumulative, you add as you go, right? So at this point, how much have I collected as I move down? Well, I've only collected 15.4, but by this point, how much total do I have?
46.2.
Yeah, 46.2. Do you guys see that? So as I move down the classes, I'm accumulating, cumulative, I'm accumulating the percentage. At the end, it should be equal to or close to 100%, so that I've collected everybody. What do I put here then? I'm collecting how much more now? Yeah, so 69.3. Collect 7.7 more. 77. And then collect 23.1% more. 100.1. Why are we not freaked out about the 0.1 at all? Because we rounded these. Exactly. So it's okay to be off by maybe at most 0.2. If you get 97% here, no, you did something very wrong. And the other way, 104%, no, you did something very wrong. But it's not going to always be exactly 100% because we rounded. All right, let me step back from that. Is the math there not intense? There's no word problems and statistics. The math is actually not that intense. I know you guys aren't going to believe me. There's just a lot of formulas. It's all the concepts. When do I use what formula? Why does the formula make sense? That's the level of difficulty. Okay. So we're here. We might as well make a histogram out of this thing. So let's make a relative frequency histogram. A rel freak hist. A real freak hist. Alright, so here's where things get a little weird. Remember I told you the goal was to do this, right? Now, is it okay if I have one that looks like, what would this mean? What would that mean?
Missing data.
Well, not necessarily they're missing data, but in this case, like in terms of this problem, there just was nobody aged that. So maybe I have a bunch of 11, 12-year-olds and then a bunch of 30-year-olds. So in the middle, it's going to be empty. So that's okay. So what can I not allow to show up? Am I missing anybody in any classes?
No.
All of these have at least one person in them. So I can't have any what in my, I can't have any gaps. So that makes sense so far. Because if I have gaps, it's going to make it look like I missed somebody. Or that nobody is in that place. So I can't have gaps. So what's kind of wrong with, this goes up to 18. This starts at 19. Oh shit. So I'm going to give you two options. I'm going to show you first the way the book does it, because you have the book to back up. Secondly, I'm going to show you the way that I do it. Some of you guys will like it, and some of you guys are maybe don't feel the best about inequalities and variables and stuff, so you're not going to like it at all. So you can use whichever one makes the most sense. I don't like this way, but that doesn't mean I'm going to take points off for you if you use it, because it's valid. The reason I don't like this way is because it's ambiguous. If I had 18.3, somebody said, I'm 18.3, where would I put that? It's got nowhere to go, right? So, here's what happens. I want there to be no gaps. Well, if I draw 11, 18, 19, there's going to be a gap right there between 18 and 19, right? Plus my scale sucks, but we'll get to that. Do you guys understand the problem? Okay, so the way that we correct for that problem is we say, all right, this isn't really 11 to 18. This is 10.5 to 18.5. So then what would this be? Now careful. 18.5, 26. Do you see how those now are going to overlap? There won't be any gaps. So this is what's called class limits, and this is what's called class boundaries. Oh, shit. Now, if you do it the other way, none of that shit happens. So this is what's called class limits, and these are called class boundaries. So, for example, this is the limit of me, right? This is the limit of me. Beyond this, I'm not there. You guys with me? Don't even get all spiritual on me or anything, right? Well, Jesse, I should. No. This is the physical limitation of me. And then I have a boundary. I have my safe boundary. Hey, step off, step back. You're getting too close. So that's the way I look at this. There's the limit, and there's the boundary. That's where it feels comfortable enough to let somebody get that close. You guys, does that make sense? I don't know. That's the way I think about it. Some of you guys are like, what class is this? He's talking about freaking spirituality and shit. Hopefully you guys understand the analogy. I love it. Some of you guys, I can tell, are just barely putting up with me, but if you're curious, so I'm not going to do a lot with this second thing because I'm going to basically use the textbook's way primarily. But the way I would do this is I would say the first class would be 11 to 19, so then I can see 8. But people get really freaked out about this sometimes. Then this would be 19 to 27. See how 8? Does 20? Where would 27? Where would 19 go? And the second one, because that's where it equals 19. Here it does not equal 19. So you can understand why people might not like this. This is a little more straight up as far as the numbering goes, but then it gets really freaky with this boundary shit. Or maybe you understand. So you can do it either way you want to, just don't do it both ways. Don't mix those ways, right? So if I go to create, oh, you missed all that. That's what I'm talking about over there. All right. Poor little person sick at home is like, what the hell is he talking about? Well, no, they might sound like that. So, doing it the textbook way, here's how this would look. I would start at 10.5. Then I would go to 18.5. And you see how now I just keep adding 8, because how wide is each class? 8. So now it's 18.5, 26.5, 34.5, 42.5. Where am I? 50.5. Yes. That's right. Stop. Make sure your scale is consistent. Some of you might even want to get some graph paper if you need some help with that. Right. What is this? What does that represent physically? Who remembers? I didn't write it down, but what is the physical situation? Ages of people at a bus stop. Two S's, Jeff. There you go. So if you don't put a label, you're going to lose points. You got to tell me what the hell it is, right? Now, I want to make a relative frequency histogram. So which set of numbers I want to use for the vertical axis? Yeah, the percentage numbers, right? If I say I want a frequency histogram, use the frequency numbers. Is that understood? I like it. Now again, your scale has to be consistent. None of your tick marks actually have to be any of these freaking numbers. That's where people get confused. I just have to be able to make it up to, what's the highest? 30.8, right? So maybe what scale do I want to use by what's? By,
Your class.
do I want to go by 7s, by 5s? Okay, I like it. So 5, 10, 15, 20, 25, 30. Sure. You guys understand what's happening?
Mm-hmm.
Hopefully you should have done quite a bit of graphing in Math 90, Math 103, 110, whatever the hell you did, or the equivalent. And of course, what is this? This is going to be relative frequency. I like this. So the label here is always either real freak or just freak. 1C. All right. Let me know that. Okay. It takes union break. So now, when I go to draw my first rectangle, how tall is it going to be?
Up to 15.
Be really careful if you do this. Don't look at these numbers, right? The first one you'll be right. The next one you'll be screwed. It wants to go up to about 15.4. Right? So it doesn't have to be perfect. Just go with 15 and then a little more. We're doing this by hand, so I can only be so critical, right? And then the next one's got to go up to 30, a little bit past 30. And then 23.1. So a little bit right in the between of those two. And then 7.7, so about halfway between there. And then 23.1 again, so I've already established that.